How's everybody doing? Last session, party afterwards. You guys ready for that? One more session? So I do have some eye candy for you, just to make it easy at the end of the day. So my name is Marc Petit. I run the enterprise business at Epic Games. By enterprise at Epic, we have a slightly different definition than the rest of the world. It's everything that's not a game. So that includes industrial applications, but it also includes film and television and broadcast, and a lot of entertainment application. And what I'm going to try to do today is to walk you through what the enterprise customers are doing with Unreal Engine, and while we're seeing this wildfire adoption of gaming technology in the industry. Give you a sense of why they're doing this and how they're doing it, and a little bit also a glimpse into the future. Because as you know the saying, I lived in Canada for a long time, you have to skate where the puck is going, not where the puck is. And the improvement in graphics are actually coming up very, very quickly. And the current generation, for example, a hardware device, is relatively light on graphics. But we have every expectation that in a few months and years, we're going to have the kind of graphics on AR devices that we currently have on PCs. So the first thing is we haven't invented real-time graphics. It's been around for 25 years. But I think what's new with Unreal Engine is that the real-time and the performance doesn't come at the sacrifice of visual fidelity. And that's really what is new about bringing gaming technology to real-time graphics, is that the quality of the experience, whether it's the visual fidelity, but also the sound and the immersion, is really what's new. So everything you see here is done at interactive frame rates. Some is 24 frames per second, some is 90 frames per second. So half of the content is VR, and it comes from many, many different industries. So as you can see, the quality of the content that's being produced, now the industry in real time is approaching the realism. But it's not just about photorealism and interactive frame rate. Why do those companies on this slide, what do they care about? First, all those guys are heavy users of Unreal Engine. And the reason why is because it supports some of their core needs in the enterprise. It's not about frivolous envy of pretty pixels. It's about improving the quality of their designs. It's about improving their time to market. It's about facilitating more collaboration inside the enterprise. It's about creating a brand and brand experience and brand stories that's actually compelling. And we are seeing those companies start adopt massively game engine technology. Why? Because the traditional tools of communication in the enterprise, as you know, are pictures and text and voice and diagrams. But now with immersive interactive media, we're starting to see the people wake up to the value of those things that we take for granted in gaming, but are very new for the enterprise. The content is live, it's produced in real time. The content is interactive. It integrates with simulation environment. It can be animated. If you are in architecture, already 30% of the architecture visualization has moved from static video to interactive. We had a survey recently promised, because when you make it yours, an interactive walkthrough is much more powerful than watching somebody else's point of view through a video. Immersivity is very important, and is driving a lot of the adoption. So you can call immersive whatever you want, AR, XR, MR, it doesn't matter to us because it's the same content. And there is also a lot of ways that you can actually create a sense of immersion, particularly with the cost of large-scale screen going down. We're starting to see more caves. We do install a lot of caves in construction companies, or just simple, those 84-inch touch screens. You know, when you stand a feet away from them, they're actually give you a pretty immersive experience. So the immersivity is very important. The other aspect that is driving game engine technology is the fact that a game engine is so much more than graphics. It's so much more than the beautiful pixel. It is a collaborative environment. You've got the network layer, the multi-user layer. You know, we are used to have, like our game Fortnite has millions and millions of concurrent users. That's very natural for a game engine. But bringing that collaborative platform in the enterprise is having actually a huge impact and is driving the adoption. And the fact that it's an open environment, the Unreal Engine is available, source code is on the internet, it's all C++, people can connect it to all kinds of sensors in their own environment, and it's very flexible. Can run on the cloud, so you can connect it to data sources. For example, you know, as we speak virtually, every single autonomous driving vehicles is being tested currently with Unreal Engine. They have those vehicles run millions of miles overnight on the cloud to test their algorithms, because the platform is very open and to do those kind of things. So that is why the companies are interested in this media. You know, they're not, when we talk to them, they don't say we want AR or we want VR. They say we want interactive content. We want to see our data interactively, immersively, and collaboratively. And that's a big draw. The other thing is people are waking up to the cost of content creation. I'm saying I saw a lot of very interesting application on the show floor in the previous panel, starting to give us a hint about the kind of things you can do with the data. But the thing we have to be cognizant about, and when we work with Accenture, for example, it's very obvious, is if getting the data to a given application involves a manual process, it will not happen, because that manual process is going to kill the economics of some of those savings on the small task. So it's very important that we integrate interactive content as a first-class citizen in the data pipeline. And we have a project called Datasmith. We worked a lot for PLM integration and making sure that that digital twin, suppose you have a car, the process of do a PLM extraction in the car and generating the version of the car that works interactively, that has the looks and behavior of the final product, that digital twin, we have to reduce the cost. That's very critical for adoption. But once you have that digital twin, the fact that you can apply it to so many of the medias, that the same assets can be used, like if you take the example of automotive marketing, where we actually see the most value. Once you have that digital twin, you have seen this yellow Lexus, for example, in the video, you can actually use it to do synthetic photography. You can use it to do commercial. You can use it to do car configuration. You can do demonstration videos with it. You can do VR experience with it. You can do large-scale display retail application with it. Usually you could do all of those, but for every media, you had to create a different set of assets, and that was expensive. Now with one asset that you can span across all of this media, thanks to the Unreal Engine platform, you can actually dramatically reduce the cost. And so that motivates the customers, our automotive customers, for example, to integrate the production of the Unreal asset in their own pipeline. Before, they would go to an agency, give them CAD data, and they would be charged over and over again for the conversion of CAD data into something usable for a given platform. Now they give away Unreal Engine assets. So that's very important. And when we say we run multiple platform, and it's the assets are multi-resolution assets. Don't want to get too much into technology, but hierarchical LODs, and there is a way that you can build those assets where you will get the best out of every single platform. If you take our Fortnite game, for example, it's the same scene, the same map, the same gameplay and blueprint that is running on an iPhone X, running at 60 frames per second on a PS4, or running on a high-end PC. And on each of these platforms, you get the best platform, the best experience that the platform can give you. So it's not the lowest common denominator. It's a lot of very sophisticated technology that makes this possible, that you can leverage your assets and fully represent on each and every one of those different platforms. So here you guys understand that the power and the value, of immersive interactive media in terms if you want to sell, entertain, convince, or explain something that's very sophisticated, you can, it's very valuable, mixed reality, as a communication tool. We're starting to see some very interesting usage. I'll show you a video. I have an example of a company called Shopify saying how they're starting to use collaboration AR and VR to solve the problem of retail for small merchants. I don't know if you know Shopify is a Canadian company. They provide e-commerce infrastructure to small merchants so that they can compete with the bigger e-commerce guys. So let's see this example of a collaborative application for a merchant.
And you're using AR to be able to preview furniture in your house. But maybe you need some help from an interior designer. Well, that interior designer could be anywhere else in the world in a virtual reality headset, and they'll just magically teleport their avatar into your space. They'll be able to see your room and help you pick that right item. You're getting this very personal shopping experience, delivered from your living room.
So that's a very interesting combination of AR and VR, and the fact that, what's very natural for a game engine, that multi-user collaboration aspect can be translated into a high-value interaction in the context of e-commerce. The other very, very strong driver and that we're seeing in companies is collaboration. Game engines allows you to create those immersive and collaborative spaces where you can actually get work done. This picture here is from BMW. We've deployed 700 VR headsets within BMW, and they do a lot of collaborative design reviews. There are two things interesting about their use cases. One is they do mixed reality in the sense that they 3D print some of the elements so that when you're immersed into the virtual car, the way your brain works, and if you see a wheel, you want to grab the wheel. So what they do, they actually use existing seats. They 3D print specific components or the dashboard so that when you are in the experience, your brain gets immersed enough and you get the full experience so that you can actually look at the design. You forget you're in VR, you're actually looking at the car, and you can make those decisions about whether the user experience in the car is actually correct. And the anecdote about BMW is that they've reached a level of comfort in their system. They put their board members and they make product validation with the board of directors in VR. So that's a pretty big win. We all heard about the NVIDIA holodeck. It's built with Unreal Engine. It's a great showcase of a collaborative use case and design review. The other thing is, in all the creative process, everything that's highly visual, collaboration and VR can be of great help. I'm going to show you an example of what happens in the film industry and how VR is actually dramatically changing how films are made.
The third floor is a frequent contributor in the visualization and virtual production of today's most epic film and television projects. The ability to execute rapid iteration of creative ideas within real-world parameters is the third floor's expertise. Demonstrated in this past season's scene from HBO's Game of Thrones is a real-time interactive visualization workflow. Capabilities include new ways to scout sets, plan practical shooting, and frame the action virtually. Advancements from the Unreal Engine are at the hub of many possible future media creation and consumption pathways and are only a beginning in a sea of possibilities for the way content can be visualized, developed, and viewed.
So it's very interesting to use this immersive environment for design. But really what we want, and the big hope of many industries, is to get to this photorealism in real time. And this year we're making a great step forward towards our vision of generating final pixels live with the introduction of RealTime Retracing that we've been demonstrating at GTC a few weeks ago. You may or may not remember the impact that ray tracing had when the movie industry adopted it 15 years ago. Suddenly, the realism of visual effects was really much improved, and 15 years later, we're bringing this technology in the domain of real time. So we made an example. We could do accurate reflections for a car, but we thought we'd do something a little bit more inspiring from an entertainment perspective. So here is a demo that was rendered 20 frames per second in real time. This is a video of it, of course, but this using the latest NVIDIA hardware is actually rendered in real time. And this is the kind of quality you can expect from VR in AR in the coming months and years.
What's the story with all the elevators lately? I heard Kylo Ren destroyed the one over in D sector.
If you ask me, who's ever in charge of this place should be transferred to Hoth. What? What?
You think she heard us? Yeah, I think she heard us.
At least we blend in for once.
So we'll get to photorealism. Ray tracing will get us there sooner than later. The other aspect that is important to us in a platform, human interact better with other human. So we do a lot of work on digital human. And we have a couple of approaches to it. The first one is, of course, based on motion capture. And I'll show you an example here how we can recreate actresses in real time. So that's the real lady. That's a synthetic version of the same lady. So we're not quite there yet, but we're getting there in terms of a realistic digital human. This technique is heavy in motion capture. It may be suitable for entertainment, but if you think about the needs to put a face on the machine, you need to actually be able to deliver in a human fashion a performance that's actually generated by AI, right? So we did a test with Andy Serkis a few weeks ago, and basically it was none of that complex mocap. It's just shot with multiple cameras. To help the algorithm, we did have a few black spots on his head to help with the tracking. And from this capture of multiple cameras, we can actually extract not only the personality of Andy Serkis, but also his performance. And you can see that we can, keep, the characteristics of Andy Serkis away and move his performance to a different character. I'm going to show you that to you. You have to imagine the use case of this being the performance being not driven by a human, but driven potentially by AI.
Tomorrow, and tomorrow, and tomorrow creeps in this petty pace. From day to day, to the last syllable of recorded time. And all our yesterdays have lighted fools the way to dusty death. Out. Out! Brief candle! Life's but a walking shadow. A poor player that struts and frets his hour upon the stage, and then is heard no more. It is a tale told by an idiot, full of sound and fury, signifying nothing.
So of course, Macbeth is not your killer app, but you have to think about this, being a way you can interact with machine, with Siri or Alexa or those kind of things. So, and this is running in interactive frame rates. I mean, the processing, the machine learning algorithms to extract the performance and and the parameterization is a very, very long process. But once you've got that, it's actually running in real time, and it could run at VR frame rates. Let's talk about VR. We're seeing a huge success and huge adoption of VR. This is kind of, for me, the high water mark in terms of visual fidelity, what we're seeing at 90 frames per second. It's a work by Simon Chidobor in New Zealand. It's beautiful work. What this gentleman does is heritage preservation, and therefore the name of the game here is to have a level of fidelity that is absolute, because this is the kind of content, this is a way to create those spaces and save them for posterity. So there was a lot of negative feelings around VR, but I think, as I said, we're seeing so much VR. We have a customer in construction. They did 115 VR experiences last year, whether it's for construction planning or for space planning. It's actually very well. In the entertainment space, we're seeing a company like The Void really advance VR to being a multi-user experience, and as well as being something that is fully sensory. In this experience, for example, you can actually touch objects, you can feel the heat of the lava, and of course you get this beautiful graphics experience that you can enjoy. So we're seeing very, very good traction of VR in location-based, and we also announced with Disney Imagineering the first interactive rides done with Unreal Engine, 8 GPUs, 5 4K projector. It's actually something quite beautiful to enjoy and fully interactive. AR, we don't quite have the compute, but this was interesting example running on the iPad. It's as was mentioned previous panel, it's a great platform for AR, but you can see real-time destruction, multiple characters, high fidelity. That is a game coming up from Peter Jackson, and its new company, Wingnut AR. We have a couple of other games as well built in AR. We don't have quite the compute, but it's coming. We do a lot of work with Magic Leap. We don't have much to show. But what's interesting for us in AR is we are actually bringing AR to a lot of other spaces. We are bringing AR with our friends at Riot Games, for example, working with our partner Zero Density, to the World Championship of League of Legends. Probably familiar with eSports. When it's the World Championship of eSports, you can bring 50,000 people in a stadium. And what Riot wanted to do is they wanted to have a game character crush the party. And this is what it gave during the World Final of League of Legends at the Beijing Olympic Stadium a few weeks ago. This is, if you play League of Legends, you recognize the character. I don't play it, but it's the dragon for the game. That is not $1 million visual effects shot done for a movie. Esports is marketing. This is something that's done with marketing budgets at a completely different scale, and a very good example of augmented reality. You'll see a lot of those on TV. We're partnering with a lot of television channels, like the Weather Channel. They announced, how they can improve the on-air experience using any form of augmented reality. So with camera tracking technology being completely commoditized, you'll see a lot of those things very, very soon. So last piece I want to show you is kind of a summary and a little bit of a glimpse into what's possible when you actually assemble all those pieces together. When you have, augmented reality at visual effects quality, in a real-time rendering environment, we can actually customize the content. You can do things. We don't have a name for that. We call it a real-time customizable movie. It's actually the hybrid child of a car configurator and a car commercial. And I'll play that video that's going to explain you in detail what it is. But I think that is a very interesting glimpse into the future, how you can use that content to do things that were not possible before. Oops.
We believe the future of filmmaking is real-time. By this, we mean that digital VFX can be generated and seen live when shooting on location, and objects within the film can be interactively configured by the viewer. On March 1st at GDC, we demonstrated this by unveiling a groundbreaking project called The Human Race in partnership with Chevrolet and Epic Games. This utilized 3 unique innovations: Epic's Unreal Game Engine, a revolutionary virtual production toolkit called Mill Cyclops, and the Mill Blackbird, an adjustable car rig which captures environmental and motion data. On a shoot, Cyclops stitches 360-degree camera footage and transmits this to the Unreal Engine, producing an AR image of the virtual object, tracked and composited seamlessly into the scene. In this case, it meant a director could frame and see the virtual car on location, reacting live to lighting and environment changes. Brands can also use this to visualize products or objects that are unavailable or don't yet exist. The Human Race also premiered the first ever interactive short film to blend live-action filmmaking with real-time game engine processing. All the cars and visual effects in the film are generated live every 42 milliseconds using the Unreal Engine. With the Configurator app, we personalized the film as it played live on screen. The film was then put through its paces by the public, who were given full control of the configurator to create their own film featuring any version of the Camaro they wanted to see. The Human Race project has generated extraordinary press coverage and viewing figures. The film is now being rolled out to other events and dealerships. Via cloud-based technology, consumers can also configure the film live online. These technologies can be used beyond car advertising. Filmmakers can see a virtual object or character rendered real-time in any live-action environment. Consumers can personalize their viewing experience by configuring any object on any screen. Brands now have the ability to create and deliver truly responsive advertising content. This is why the future is real-time.
So this is the future is real-time. It's photorealistic. The work we do with the enterprise, now in the enterprise space, all about the data. As I mentioned, it's all about making sure that that digital twin that has so much value because it brings so much value in an AR, in a VR experience, or an interactive experience. Reducing the cost of the production of that digital twin, eliminating the data prep is our focus. And we think it's the key to see much more adoption of those technologies. And then the proliferation of devices, whether they are MR, VR, XR, or whatever, I think will happen. And so we're very hopeful, and it's happening faster than it feels from the outside for the people outside the industry, pointing at the lack of volume on devices. But we are starting to see the enterprise building the data infrastructure. And when the hardware are ready, it will happen. It will be already there. Thank you very much.
Thank you.
Welcome.
There are a couple of questions. Before we get into the questions, I wanted to just, for those of you who might be wondering why we have gone a little longer than this session, the speaker that was to be here from Johnson & Johnson's actually in another room. So we're happy to have Marc here and to take some time, a couple minutes for some questions, and then we'll continue with the program at 20 after. Thanks.
Okay. All right, how do you handle code switching? I would need a little bit more context to understand this question, so whoever, maybe we can talk about it after I'm off the stage. Do you expect smaller companies to also benefit? Absolutely, and that's one of the importance of ray tracing is it can be a daunting task right now to take a game engine and create a photorealistic image with it because it's a little bit complex. But ray tracing is such an easy simulation of a real life lighting that it's, even myself, I'll be able to light, I can light a scene with ray tracing because I have to put lights like I would do here. It's very intuitive. So I think that is absolutely how we're going to drive the usability, the ease of use down market. The technology is already very accessible and very affordable. Technology is free if you don't need support. Source code is on the internet, so that's really satisfactory for the indie. And we have 5 million users at the moment, and that is a number that's growing rapidly. So we have mass adoption across smaller companies.